Okay, geometry, we're going to move into section 11.1 here, and this textbook throws a lot of content into chapter 11 and a lot of content specifically into section 11.1. So I'm going to break this up into probably two videos here, but anyhow, let's get rolling on this right now. So we're going to start with areas of parallelograms here. So the whole section is on quadrilaterals, and I think we've got four different ones to talk about, but we begin with the most basic of these formulas, which is the area of a parallelogram, and that formula is given to you right here, guys. Area of a parallelogram is simply going to be B times H, where B is going to represent the base of your parallelogram, and H is going to represent the height. So we got a little diagram over here on the right, and hopefully you guys will remember from a previous chapter that a parallelogram is a quadrilateral with two pairs of parallel sides. So I probably should have had arrows drawn and a double arrow here on the left, and also a double arrow here on the right. And this formula here is the most basic one we have in this chapter, and it's simply B times H. Now the reason for that, if we want to get into it, basically boils down to this idea that a rectangle is probably the easiest shape to take the area of. If I were to tell you that we were dealing with a rectangle that was, say, 3 by 4, think about a very small room in your house, maybe that's 3 feet by 4 feet, like a closet or something like that. If I were to just cut this thing up into a series of small squares, you'll notice I've got 1, 2, 3 of them on the left-hand side, and then 1, 2, 3, 4 of them here on the bottom. And if we were to count up how many of those square tiles it's going to take to fill in that space, you're going to end up with 12. And of course, you'd realize you're just multiplying the 3 by the 4. This is probably how multiplication was explained to you back when you learned it for the first time, maybe in 3rd or 4th grade. So that formula works for the area of a rectangle. It's simply its base times its height. Well, what we're doing now is we're essentially taking, I'm trying to look at this figure that we have right over here, we're essentially taking part of this rectangle and just chopping it off. So if I took this piece in red and just chopped it off the rectangle right there and then moved it, that's not what I wanted to move, there we go, over to the other side and kind of erased what I had chopped off right there. Now if we kind of take a look here, guys, we are dealing with a parallelogram, and we really haven't changed the size of the figure at all. Back when, ooh, give me the red, nope, come on, come on. That's going to be harder than it should be. Back when that red triangle was over here, we had that area of 12, and moving part of it to the other side really hasn't changed the overall side of the figure. So this same formula here, guys, base times height, is going to work for any parallelogram, whether it's a rectangle or not. However, there is one really important idea that we need to get, and I want to make sure that you guys have this in your notes right here. And this statement we're about to write is going to be true pretty much through all of chapter 11, and that is going to be that base and height, here we go, must be perpendicular to each other. Make sure I'm spelling that right. There you go. Base and height must be perpendicular. So you'll notice in this diagram that I drew that we've got a right angle right here. That's the key in any problem that uses the words base and height. Now, when you first learned about area, maybe in elementary school or middle school, you probably were taught that base means on the bottom and that height means that it has to run vertically. And that's certainly the case we all like to think about it, but it doesn't have to be that case all the time. So I'm going to come back to this idea here, guys, over and over and over again, not just in this section, but in all of this chapter where we're dealing with area, surface area, and volume. So we want to make sure we understand that idea. And I think in the second example we're going to do, it'll kind of be illustrated for you. But let's start with a relatively basic one here. And again, guys, I got a little lazy on my diagrams. I should have been putting arrows here and here, and then a double arrow here and here, because we should know not to make visual assumptions. So now with the arrows, we know that this figure is a parallelogram, and we're going to come up with the area for it. Now, formulas are going to be really, really important to us in this chapter, and so I really want you guys to get into good habits here of learning a 3-step method for dealing with problems that require a formula, specifically area, volume, things like that. And step number 1 is to write down the formula. This is a parallelogram, and the formula we just learned for area of a parallelogram is base times height. So step 1, start with that formula. Step 2, fill in everything that you know. Now there are 3 variables in this formula: area, base, and height. no matter what formula we're dealing with, you have to be able to know the values of every one of those variables except one. So in this case, since we have 3 variables, we need to know the value of 2. We don't know the area yet. That's what we're trying to find, but we better know base and height. Now, again, everybody thinks that the base needs to be located on the bottom of a figure, and that is often the case, but not always. So you kind of have to think ahead and say, okay, if 11 is my base right down here on bottom, do I know the length of a side here that is perpendicular to that base? Because I want to go back to this comment right over here. Base and height have to be perpendicular to each other. And you'll notice in this problem, guys, I actually gave you 3 measurements, 11, 6, and 7, even though we really only need 2. This is high school geometry. We're not trying to make this super easy for you guys. So base and height, if 11 is the base, do we know the length of a piece that is perpendicular to it? Well, there's my right angle, and 6 would end up being the height. So the base is going to be 11 centimeters, and the height then is going to be 6 centimeters. And this 7 centimeters here, which is the length of this other piece, the other side of the parallelogram, ends up being what we call extraneous information. It's not wrong, it just doesn't help us in this problem. But I need to make sure that you guys understand that 6 is the height because it's perpendicular to the base, which is 11. And then step 3 is to go ahead and, in this case, evaluate, just multiply out that right side, but sometimes that involves solving. So 11 times 6, hopefully we don't need a calculator here, that's going to be 66. Let's talk units for a second, guys. Centimeters is a measure of length. How long is our base? 11 centimeters. And again, the height is what we call a linear measurement as well. But when you multiply centimeters times centimeters, you get a new unit now for area. And just like in algebra, when you multiply x times x and you get x squared, kind of the same thing happens with units here. Centimeters times centimeters is going to get us a new unit called square centimeters. Now, a lot of people say that incorrectly, and a lot of math teachers you guys have had up until this point have probably said it incorrectly and allowed you to say it incorrectly. A lot of people want to read it the way we write it, which is centimeters squared, but we're actually supposed to say square centimeters. And another way of writing this back in the day used to be this, square centimeters. You'd see it written that way in a lot of textbooks because it was easier for publishers just to type that rather than write it with the exponent. So this is our answer here, guys. The area of this parallelogram is 66 square centimeters, and let's try to say that one correctly. Okay, that problem was pretty straightforward. You were given the base and the base was on the bottom, and the height ran vertically. But the plot thickens when you see a problem like this one here. So you'll notice now I've given you the lengths of both sides of the parallelogram, 8 feet and 12 feet. And the 8 is on the bottom, so you'd probably like to think that 8 is the base, but we're going to run into an issue here in just a second. I'm getting ahead of myself, though. Start with a formula. Area of a parallelogram, that's what we're dealing with here, is once again base times height. Step 2, fill in what you know. We don't know the area, that's what we're trying to find, and we've got to determine what the base and the height are. So what you really need to do in all of these problems, you guys, is look for the right angle. You've got to have a perpendicular line here. Really, that's an altitude. If you don't have a right angle, then you don't actually know the height of your figure. So there's our right angle, and ask yourself what 2 sides are perpendicular to each other. It would be this piece right here and this piece right here. And let me go back to that first slide and hit it yet again, everybody. Base and height must be perpendicular to each other. So it's going to be tempting for you guys to think that 8 is the base because it's on the bottom, but I don't know the length of a side that's perpendicular to that 8. So instead, I'm going to use the 12-foot side here for my base. This can be my base now, and then this would be my height because it's perpendicular to it. So 7 feet then ends up as the height. And the big idea here is this, guys. This is the difference now between high school geometry and middle school geometry. The figure here can be flipped, guys. If I were to group all of this together, ooh, does this work now? Let's try it. Okay, there you go. If I were to take this whole figure now and flip it around, Okay, I know the numbers aren't facing the right direction for us, but now, okay, the 12 is on the bottom, if that's the way you want to think about it, and the 7 runs straight up and down. It's all relative here, guys, so the direction that the figure is facing in the original diagram really doesn't matter. You can manipulate that any way you want. So I will reiterate, the base can be any side of the original figure, but the height has to be perpendicular to it. So let me kind of put that back where it was. All right, and let's finish this up now, guys. So step 3, let's evaluate. Area equals 12 times 7 is going to be 84. Feet times feet is going to get us square feet. Not feet squared, but square feet. And that's the area of that figure. So what I'm hoping to accomplish with this example, guys, is the idea that base doesn't always need to be on the bottom. Height doesn't always need to run straight up and down vertically. They just need to be perpendicular to each other. Okay, and now this is a great geometry problem here as well. So we've got this figure, and again, I should have put arrows right here, because especially with a hand-drawn diagram, you'd never want to assume. Okay, and now we've got 2 pairs of parallel sides. So this is a parallelogram. And step 1 is to write the formula out. Area of a parallelogram is simply base times height. Step 2, fill in what you know. We're still looking for area now. And base and height need to be perpendicular to each other. Well, there's the right angle. So that means that 8 right here is going to be the base of this figure. And we're talking inches. And now we need to know the height. And if this was a multiple choice question, I would absolutely put 96 for one of the 4 or 5 choices right there, and I would expect a lot of people to pick that. Why? Because I need 2 things here for area, base and height, and I've only given you 2 numbers, 8 and 12. So I think a lot of people would mistakenly put 12 inches here for the height, and then multiply 8 times 12 and get 96 and be on their merry way, just assuming they got this problem right. Why is that incorrect? Because the 8 and the 12 are not perpendicular to each other. And I'm going to keep coming back to this idea over and over again, guys. Base and height have to be perpendicular to each other. So back to this one right here. I got to undo some of that junk I just did right there, guys. Let's get rid of some things there and there and there, and let's get rid of that and that. Okay, here's the right angle. Right over here. So if 8 is your base, that's fine, but this red altitude right here has to be the height, and we've got to figure out the length of that. So how are we going to do that? Well, remember, guys, math people who write problems for you usually don't give you extraneous information that often, although I definitely did that in the last 2 problems. But that 60-degree angle right here is important, guys. What that means we are dealing with right here in yellow is a special right triangle. There was a 60, there was a 90, and that means that this has to be a 30-degree angle right up on top. And with that information, guys, we can find h. Now, how am I going to do that? I'm going to take advantage of the fact that this is a property we learned of parallelograms back in the day. Opposite sides, in addition to being parallel, must also be congruent to each other. So if this right side of the figure is 12 inches, this left side of the figure has to be 12 inches as well. And now, I don't love where I put everything in this figure, guys. Sorry, we're dealing with a 30, 60, 90 triangle there in yellow, and we know the length of the hypotenuse. So let's see what we remember from the last chapter. How do you go from hypotenuse to short leg? You're going to divide by 2. So this bottom side right here is 6 inches. And then, how do you go from short leg to long leg? We multiply by the square root of 3, so the height here is going to be 6 root 3 inches, and that's what was missing right here. 6 root 3 inches is the height of that parallelogram. So, had to use some information about trig that hopefully we remember from a previous chapter. And now on to step 3. Let's finish it all up now. And you can use your calculator here if you want, but you really don't need it. 8 times 6 root 3. You ignore the root 3 for a minute. Just multiply the 8 times 6 to get a 48. And the root 3 really just tags along for the ride. And then inches times inches get you square inches once more. Okay, so just like hopefully this is a habit we got into in our trig chapter, we want to leave our answers in simple radical form anytime that we can. So 48 root 3 is probably the best and most accurate answer that we had for that. All right, guys, that's as much as I was going to do with you with parallelograms, but I'm going to take a minute right now and start talking about triangles. Now, in the textbook that we're in this year, the McGraw-Hill book, they covered area of a triangle earlier on in the book. They don't actually introduce it in this section, but this particular year, we haven't covered this concept yet, and it seems like a good time to throw it in. So the formula for area of a triangle, you're going to notice, is really similar to the formula we just dealt with for area of a parallelogram. Area of a parallelogram was base times height. Well, the formula for area of a triangle just puts a 1/2 in front of that. 1/2 times base times height. Now, the reason for that, guys, you'll take a look at this diagram that I have drawn over here to the right. And once again, same concept right here, guys, that base I've drawn on the bottom and height I've drawn vertically, but they've got to be perpendicular to one another. Now, if I don't think you guys want to put this in your notes, but real quickly, if I were to draw a box, a rectangle, effectively, around this triangle, you'll notice that I've just drawn a rectangle here with a base of, well, yeah, B, same as the base of the triangle, and a height of H. And so the area of the parallelogram, we just got done talking about this, is the product of base times height. And the cool thing about this here is, guys, now you'll notice that we've drawn a triangle inside of that rectangle. And if I were to cut that thing in half, like right here, you guys will notice, let me switch back to blue here because that's what color the triangle was, that what I'm shading right here makes up exactly half of this rectangle. I've got this unshaded region right over here that's exactly the same size as the shaded region. And then if I move over to the right and look at this rectangle here, this shaded portion once again makes up exactly half of that rectangle. So if I were to undo all the messy markings that I just made right here and ask you guys this basic question, out of the purple rectangle that I just drew, the blue triangle makes up how much of that rectangle? The answer is going to be exactly 1/2 of it. So the area of a triangle is simply 1/2 of base times height, or 1/2 of the area of the rectangle that kind of encompasses it. So let's run through this one. I've got a couple of examples here that are harder for you than the ones that we just did with parallelograms. Let's see what we've got. So we're dealing with a triangle here. So step one, write down your formula. Area of a triangle now is 1/2 times base times height. Step two, fill in what you know. We don't know area. We're looking for that. But we need to know both the base and the height of this entire triangle. Well, my base is this entire bottom side. I say that because I've got a right angle right here, guys. And so it looks like my base of this figure is going to be 20. The height, though, is going to be this piece right over here, and that's unknown right now. But I do wonder, why was I given the 17 and the 5 in this figure right over here? Well, the key to that, guys, is because we now have right triangles within this figure that can help us figure out what H is. If the whole bottom side is 20 and 5 of that 20 is used up over here on the left, I can just subtract, and that tells me that 15 of those units are used here on the right. And now, if we take a look at this triangle that we have right here, guys, I see that it's a right triangle with a leg of 15 and a hypotenuse of 17. And that makes me think, ooh, I could use the Pythagorean theorem to figure out what H is, because it's a right triangle, two sides are known, and one is unknown. Or better yet, if I learned my Pythagorean triples from back in the trig chapter, I know that this is an 8, 15, 17 Pythagorean triple, so H has to be 8. And that tells me what I was missing right here, guys, in my formula for area of the triangle. Now, again, I think Pythagorean triples are a really cool thing, and I think you guys should memorize them and learn how to use them. But if you don't, you could do the Pythagorean theorem there, and I promise you, you will get 8 for the length of H. But it's a lot faster if we happen to know our triples. And now for step 3, area of the triangle. Let's just multiply it all out. You could certainly use your calculator and ask it what's 1/2 times 20 times 8, but I'd really like you guys to try to do this without it. You can just multiply 2 of these things here together. What's half of 20? That just becomes 10, and the 10 times 8 is going to give us 80. Now you'll notice I didn't give you any units in this problem, inches, feet, centimeters, anything like that. So when that happens, we just generically put a U for units, and again, because this is an area problem, it would be square units. So 80 square units is the area of this triangle here in example A. Example B is a little bit tougher. Okay, here's the figure that we have, and I do see a right angle, but it's way out here outside of the figure. Okay, interesting. So let's get to it. All right, step number 1, area of a triangle. We write the formula first, is 1/2 times base times height. Step 2, fill in what you know. Area of the triangle is 1/2 times. Okay, so first I need the base of my triangle here. And guys, you'll notice that what I've drawn outside of the figure here with those dotted lines, those are called auxiliary lines. They're to help you measure things here, but the triangle itself is defined by those thick black lines right there. So the actual base of the figure would need to be one of the sides of that triangle. And I've got to look for where the right angle is here, and that means that the base of this triangle is just going to be this 40-inch segment right here. So 40 inches, not 48 and not 50, 40 is going to be the base of this triangle. And the height of it then would have to be the length of a piece that goes from the top of the triangle here perpendicular to the bottom. So this piece over here on the right, which is outside of the triangle, that's our height. And how in the world are we supposed to figure that one out? Well, the interesting thing about this is you have to take a look at this larger triangle that's been drawn for you here that I'm going to redraw off to the side. Now, this right side here is H. The long side, which is actually the hypotenuse of this right triangle here, is going to be 50. And then the whole bottom side from here all the way over to here, I'd add the 40 and the 8 together to get 48 for the length of that piece right there. So how are we going to figure out h? Once again, guys, you could do the Pythagorean theorem. H squared plus 48 squared would equal 50 squared. However, I noticed something right here, maybe you guys do too, that 48 and 50 are both even numbers, which means they can both be divided by 2. So let's just see if this gets us anywhere. 48 divided by 2 is 24. 50 divided by 2 is 25. Oh, this is a 7, 24, 25 Pythagorean triple. So I'd put the 7 there, and then I would multiply out. 2 times 7 tells me that h is going to have to equal 14 inches in this figure, and that's what's going to go right there, guys. All right, so our height is 14 inches. Again, you could have done the Pythagorean theorem. You would have gotten the same answer, but it's much faster if you guys know your triples. This time, what I think I might do is multiply the 1/2 and the 14 together. You can multiply 3 numbers in any order that you want. Half of 14 is 7. And 7 times 40, well, 7 times 4 is 28. Stick a 0 on the end, 280. Inches times inches, that's going to get us square inches. And that's our answer here for example 2b. So definitely in some of these problems, you've got to do some digging in order to figure out a missing measurement. Now, at this point, I wouldn't be surprised if a lot of you guys are saying, okay, this seems silly and like it's a waste of time. We really don't need to write out all 3 steps here the way he's doing in each one of these problems. Well, this is geometry, guys, in high school, not middle school. You're going to see some harder problems, and this would be an example of it. Now, if you take a look at this example, this one is different than the, what has it been, guys? 1, 2, 3, 4, 5, than the 5 examples we've done prior to this. In this problem, the area has been given to you, and you're being asked to solve for x, which is a side length within this triangle. However, I do notice that it's a triangle, and they've given us the area. So I'm still going to write the same formula here in step 1. Area of a triangle is 1/2 times base times height. Now, in the previous 5 examples, we've known B and H, and we were trying to figure out what A was. But now things are different. So we go to step 2, and what I've said in the previous 5 examples is fill in what you know. Now, much earlier, I said, all right, if there's 3 variables here, you've got to know the values of 2 of them to be able to figure out the third. The same is true here. We now know the area, guys, and that is 126 square millimeters. That's going to equal a 1/2 times. Now the base and the height of this triangle have to be perpendicular to each other. Well, I've got my right angle right here, and that tells me that 12 is going to be my height. This amount right here is going to be our base. So the base here is going to be x, and the height of this figure is going to be 12. So this is the type of problem where the 3-step method here really helps you out, guys. Now step 3, in this case, I can use the word solve because we're trying to isolate our variable. So I'm going to leave the left side alone, 126, and on the right side, I'll simplify 1/2 of 12. That's going to get us 6. Being multiplied by x. And now we're simply going to divide 6 on both sides right here, and we should get our answer now that x is equal to 21. Everything you'll notice was measured in area was square millimeters and height was millimeters. Really what's happening here, guys, is this is 126 square millimeters divided by 6 millimeters, and square millimeters divided by linear millimeters is going to get us just millimeters again, because we're not finding an area right now, guys. We're finding a length in this figure. So 21 millimeters would be our value there for x. All right, everybody, that's as much as I'm going to go through in this video. I'm going to come back in the second part and we'll dive in with areas of trapezoids and rhombuses and kites. But that's a wrap now on parallelograms and triangles, the first half of 11.1.